Hi everyone, I'm Ava. Today we're going to be looking at the AMC 2020 problem set. So because there was COVID in 2021, so there's only the 2020 problem set as opposed to the 2021 one. So without further ado, let's get started. So problem 1. Luca is making lemonade to sell at a school fundraiser, and his recipe requires 4 times as much water as sugar and twice as much sugar as lemon juice. Uses 3 cups of lemon juice. How many cups of water does he need? So we know already that the ratio of lemon juice to sugar to water is 1 to 2 to 4. And if he uses 3 cups of lemon juice, then accordingly as well, this would multiply by 2 to get 6. And this would multiply by 4 to get 24. So eventually we know that he used 24 cups of water. And for this problem, what you should be thinking about is ratios, and how do these ratios appear, and how can we write these ratios out and ensure that the ratio is equal. So problem 2. 4 friends are doing yard work for their neighbors over the weekend, earning $15, $20, $25, and $40 respectively. They decide to split their earnings equally among themselves. In total, how much would the friend who earned $40 give to the others? So the friend who earned $40 is going to have to give a certain amount to the others. And each of the friends should, in the end, have the same amount of this average number of dollars. And that would be the average of all of their earnings divided by 4. And so when we add up the top and the bottom, we get 35 plus 25 equals to 60. And 60 plus 40 is 100. So the overall sum is 100, and 100 divided by 4 is 25. So the friend who earned $40, they have to end up with 25, which means they will be giving away $15 in total to all of their other friends. Problem 3. Carrie has a rectangular garden that measures 6 feet by 8 feet. She plants the entire garden with strawberry fruits and is able to plant 4 strawberry fruits per square foot and harvest an average of 10 strawberries per plant. How many strawberries can she expect to harvest? So first, the total area of her farm is 6 times 8. And she has 4 strawberries in each of these square feet and 10 strawberries from each of the plants. So that equals to 48 times 40, which is 192 times 10 is 1,920. So the answer is D. Problem 4. 3 hexagons are increasing in size as shown below. Suppose the dot pattern continues so that each successive hexagon contains 1 more band of dots. How many dots are in the next hexagon? So the first hexagon has 1 dot. The next hexagon has 1, 2, 3, 4, 5, 6, 7 dots. 7 equals 1 plus 6. And the next hexagon has 7 plus 12 dots along the outer edge. 12 dots along the outer edge. And so that equals 19. And so we can assume here that with each successive hexagon, the amount of dots around the outer edge is going to increase by 6. So then the next number of dots around the outer edge would then be 18. So it's 19 plus 18, which equals 37. Problem 5. 3/4 of a pitcher is filled with pineapple juice, and the pitcher is emptied by pouring an equal amount of juice into each of 5 cups. What percent of the total capacity of the pitcher did each cup receive? So there's a total of 3/4 of a pitcher, and then it is split evenly among 5 cups. So we perform this fraction division to get 3 over 20, which equals to 15%. So this means that 15% is placed into each of the cups, and so the answer is 15. Problem 6. So there's 5 people that's in this train, and there are 5 cars that each have 1 seat. Maren sat in the last car, Aaron sat directly behind Sharon, and Darren sat in one of the cars in front of Aaron. At least one person sits between Karen and Darren, who sat in the middle car. So we know that there are 5 seats, and Maren sat in the last car. Aaron sat directly behind Sharon, so they're somewhere like this. And Darren sat in one of the cars in front of Aaron. At least one person sat between Karen and Darren. So we come to this solution where we have Darren in the first car, then Sharon and Aaron, and finally Karen. So the person that sat in the middle car was A, Aaron. Problem 7. How many integers between 2020 and 2400 have 4 distinct digits arranged in increasing order? So for it to be in increasing order, it has to be something 2, 3. And the 10th digit must start from 4. So then we have numbers 45 to 49 that are viable. That accounts for 5. 56 to 59. 67 to 69, 78 to 79, and finally 89. So then we have a total of 15 ways in which these 2 digits could be increasing. So the final answer is 15. Problem 8. Ricardo has 20 coins, some of which are pennies and the rest of which are nickels. And he has at least 1 penny and 1 nickel. What is the difference in cents between the greatest possible and the least possible amount of money that Ricardo can have? So the greatest possible amount of money that he could have would be 2019 nickels, since we want to maximize the number of 5-cent coins that we have and minimize the number of pennies that we have. However, we need at least 1 penny, so that we still need to have 1 remaining penny. And the minimum amount of money that he could have would be to have 1 nickel and to have 2019 pennies. So to subtract those, we get, and this equals to 2018 times 4, which is as follows. Which was 8,072, so the answer is C. Problem 9. On Akash's birthday, he is given a 4 times 4 times 4 inch cube. The cake has icing on the top and the 4 side faces, and no icing on the bottom. Suppose the cake is cut into 64 smaller cubes. How many pieces will have icing on exactly 2 sides? So the number of cubes that have icing on 2 sides are these cubes on the top and these 3 cubes and these 3 cubes, as well as the ones that are not facing us on the other side. So for the cubes on the top, that is 4 times 2, and the cubes on the side is 4 times 3. So the final answer is 20. Problem 10. Zara has a collection of 4 marbles, an Aggie, a bumblebee, a steely, and a tiger. She wants to display them in a row on a shelf, but does not want to put the steely and the tiger next to one another. And how many ways can she do this? So there are a few ways that she can put the steely and the tiger. First way is like this. The second way is like this. And the third way is like this. So then that is 3 ways. And for each of these 3 ways, she has 2 ways to put the steely and the tiger, and 2 ways to put the Aggie and the bumblebee. So that accounts for a total of 12 different ways, and so the answer is C. Problem 11. After school, Maya and Naomi headed to the beach, 6 miles away. Maya decided to bike while Naomi took a bus. The graph below shows their journeys indicating time and distance traveled. What is the difference in miles per hour between Naomi and Maya's average speeds? So miles per hour is calculated as distance divided by time. So in this case, Naomi's miles per hour would be 6 divided by 1 over 6 hours, which equals to 36 miles per hour. Maya's miles per hour would be calculated as 6 divided by 1 over 2 equals to 12 miles per hour. So they have a difference of 24 between the two. Problem 12. For a positive integer n, the factorial n factorial represents the product of the integers from n to 1. For example, 6 factorial equals 6 times all the way to 1. What value of n satisfies the following equation? So we can actually write out this equation because it'll help us to visualize what this actually looks like. So to find the next factorial, we want to find a way to form 10, so we can multiply with 9 and then form 10 factorial. So then we can take 12 here and cross it out with 3 times 4, and we actually get 10 here. So n equals to 10. Problem 13. Jamal has a drawer containing 6 green socks, 18 purple socks, and 12 orange socks. After adding more purple socks, Jamal noticed that there is now a 60% chance that a sock randomly selected from the drawer is purple. So what it's telling us here is that it has a total of 36 socks. And when it has 18 plus n, which is the added purple socks, over 36 plus n, there is a 3 over 5 chance that it gets a purple sock. And so this equals the following equation when you multiply it out. And so the number of added socks we can get is 9. Now this problem, you just need to write out this equation, and then you solve it and everything will be a lot easier. Problem 14. There are 20 cities in the county of Newton, and their populations are shown in the bar chart, with the average being the horizontal dashed line. Which of the following is closest to the total population of all 20 cities? So now total population will equal just average times 20. And it already shows us the average with this line here. Now this here is 5,000. This is 4,500. And so the average is 4,750. So that means that the total equals this. So the closest that it is closest to is the answer D. Problem 15. Suppose 50% of x equals to 20% of y. What percentage of x is y? So actually here we could simplify this even more to get this. So now it asks us what percentage of x is y. So that means we need to write y equals something something x. So we bring it here, y equals 3 over 4x, which equals 75%, and the answer is C. Problem 16. Each of the points A, B, C, D, E, F in the figure below represents a different digit from 1 to 6. Each of the 5 lines shown passes through some of these points, and the digits along each line are added to produce 5 sums, 1 for each line. The total of the 5 sums is 47. What digit represents B? So for this problem, what you need to do is you need to add up all of the lines and find out how many of each number that is added up to produce 47. And then based on that, you can actually see a pattern. Right, so here I've written down all of the lines out and what they look like with like, what letters on each line and so on. So now we see a pattern here is that there's 2 of every number except for B, which has 3. And we already know what the sum of A to F is. So we can just have 47 subtracted by 2 times 7 divided by 2 times 6. And that equals 47 minus 42, which equals to 5. And so the answer is E. Problem 17. How many factors of 2020 have more than 3 factors? For example, and it gives like some examples. And so the first step when this problem tells you how many factors of 2020 is you need to prime factorize 2020 to see what factors it has. So we get 2 to the power of 2 times 5 times 101. And so this means that there are 12 total factors. And we get that through 3 times 2 times 2 equals 12. And recall that when you have a number like n times m, you actually get 2 times 2 equals 4 factors. And so for a number to have less than or equal to 3 factors, it's either going to be n to the power of 2 or it's just going to be n. So for the numbers that have less than or equal to 3 factors, we get 1, 2, 4, 5, and 101, which is 5 numbers. And so 12 minus 5 equals 7, which is our final answer. Problem 18. Rectangle ABCD is inscribed in a semicircle with diameter FE, as shown in the figure. Let DA equals 16, and let FD equals AE equals 9. What is the area of ABCD? To find the area of ABCD, we need to find one of the side lengths of this, since we need to find either BA or CD, since we know that DA, our base, is already 16. So if we write out the length of this, we know that the whole radius equals 8 plus 9, which equals 17. And now, remember that radius of a circle is the same in all directions. So this here equals 17. And so BA equals 17 squared minus 8 squared equals 289 minus 64 equals the square root of 225, which equals 15. And so the area of ABCD is 16 times 15, which equals 240. And so the answer is A. Problem 19. A problem is called flippy if its digits alternate between 2 distinct digits. For example, 2020 and 37373 are flippy, but these numbers are not. How many 5-digit flippy numbers are divisible by 15? So 15 has factors of 3 and 5. For a number to be divisible by 5, it must end on 0 or 5. For a number to be divisible by 3, the digit sum also has to be divisible by 3. So that means that first it tells us that it can end on 0 or 5, and that's like very helpful to us because at the same time its digits must alternate between 2 distinct digits. So if it ends on 0, it would be something like this. However, this is not correct because you can't have a first digit that is a 0. So we know that it must end on 5, and so it's got to alternate like this, where you have some numbers x in the middle. And 5 plus 5 plus 5, when you add it all up, it's already divisible by 3. So the number of x, it also has to be a multiple of 3. So then the only digit multiple of 3s that you have is 0, 3, 6, 9, which is 4 of these. And so the answer is B. So this problem, you're basically just dealing and playing around with divisibility rules, and as well as number and the inherent limits that they have to them. Problem 20. A scientist walking through a forest recorded as integers the heights of 5 trees. She observed that each tree was either 2 times as tall or half as tall as one to its right. Unfortunately, some of her data was lost when the rain filled her notebook, and based on her observations, what was the average height of the trees in meters? So look at the first number that it gives you, or like the only number here, 11 meters. So tree 1 has to be 22 because 11 cannot be divided by 2. And tree 3 must also be 22. And then look at the average it gives you. If the sum were to be divisible by like 5, for example, it was 55, then the average is going to be 11. However, the average is 0.2, which means that the sum of all these numbers is not divisible by 5. And already the sum of these is 55. So we can ignore those and just think of the tree 4 and tree 5. These trees, their sums must not add up to be divisible by 5. And at the same time, there are the selections are already given to us. So we know that the average has to be around 20-ish or slightly larger than 20. But we notice here that the current trees that we have are all 22 or less. So we need a tree to bring up the average. So let's use like 44. And then 44, if we multiply to 88, first that's like unrealistic. And second is that it would bring up the average to be too large. So then the tree 5 has to be 22. So then our final sum is 55 plus 66, which equals 121. 121 divided by 5 is 24.2. So the answer is B. Problem 21. A game board consists of 64 squares that alternate in color between black and white. The figure below shows P in the bottom row and the square Q in the top row. A marker is placed at P, and a step consists of moving the marker onto one of the adjoining white squares in the row above. How many 7-step paths are there from P to Q? So if we remember that there are some questions where it tells you to go from start to end in a grid of numbers. And to find the number of paths to do that, you would put all of these numbers in the columns and in the first column and the first row as 1, and then find the sum of these. So we can take that same logic and set this to 1 and all of these to 1. Then add this up to be 2. Add this to 3, 3, 4, 6, and this is still 3, 9, 10, 19, this is still 9, and 28. And so the final answer is A, which is 28. Problem 28. There is a machine where, if n is even, it outputs n divided by 2. If n is odd, it outputs 3n plus 1. Starting with that input of 7, the machine will output 3 times 7 plus 1 equals 22. When the same 6-step process is applied to a different starting value of n, the final output is 1. What is the sum of all such integers n? Now we go back here and we see that it tells us that n has to be a positive integer. This means that the only way to get to 1 is n divided by 2, because if the next number were to be odd, then the next number would be 0, which is not a positive integer. So this is 2. And this is 4, since 1 is not divisible by 3 into an integer. 4 can be 8, or it can also be 1. 8 can be 16 only. 1 has to be 2, and it has the next one to be 4. This equals 8, and this equals 1. So now we've gone to our 6th step, and 16 here, it can equal either 32 or 5, and then 64 and 10. The sum of all possible n's is as follows, is 83, and so the answer is E. Problem 23. 5 different awards are to be given to 3 students. Each student will receive at least 1 award. How many different ways can the awards be distributed? So for all these awards, for every student to have at least 1 award, there are only 2 ways in which the awards can be given out. There's these ways. So for the first one, you would first choose 2 awards to give to one of the people that got 2 awards. Then you would choose out of the 3 remaining awards 2 awards, and then finally out of those you choose 1 award out of 1, and then finally you scramble this in 3 ways. Now this comes down to 10 times 3 times 1 times 3, which equals 90. Next scenario is 5 choose 3, 4, 2 choose 1, 1 choose 1, scramble it 3 ways, equals 10 times 2 times 1 times 3 is 16. So the total sum is B, which is 150. Problem 24. A large square region is paved with n squared gray square tiles, each measuring s inches on a side. A border d inches wide surrounds each tile. The figure below shows the case for n equals 3. When n equals 24, the 576 gray tiles cover 64% of the area of the large square region. What is the ratio d divided by s for this larger value of n? So when we write this out as an equation, we know that there are 24 square different gray tiles, each measuring s squared area. And the total area of this whole square is 24s plus 25d squared equals 64 over 100 equals 16 over 25. So 24s divided by 24s plus 25d equals 4 over 5. So 25 over 24 times d over s equals 1 over 4. So d over s equals 1 over 4 times 24 divided by 25 equals 6 over 25. So the answer is A. Problem 25. Rectangles R1 and R2 and squares S1, S2, S3 combine to form a rectangle that is 3,322 inches wide and 20 inches high. What is the side length of S2 in units? So let's assume S2 has a side length of S, S3 has a side length of A, and R2 has a side of B. A plus B equals to 20. And 2A plus S equals 3,322. At the same time, we know that S equals to A minus B. And when we subtract 20 from 3,322, we get A minus B plus S equals 1,302. A minus B plus A minus B equals 1,302. So 2s equals 1,302 and s equals 651. So the answer comes down to A. Okay, so these were the problems for our 2020 problem set. And if you have any problems, you can leave them in the comments below. And make sure to subscribe for more tutorials in the future. Bye-bye.